Alrighty, happy Monday, 7th graders. So today we are going to work on combine like terms. Okay, in your textbook, this is chapter 5, lesson 5. Alright, today we want to make sure that we're able to identify and use mathematical properties to simplify our algebraic expressions. And that's what we're doing when we're combining our like terms. We are simplifying those expressions so that when we're given then a value for the variable, we can plug it into the expression and evaluate, compute, find our final answer. And the reason why we do this is because next year when you get in 8th grade, you're going to have more complex equations that you're going to have to break down and solve using these properties and combining like terms. Okay, so let's talk about some modeling. Okay, I am going to drag over for each of these expressions what it says is modeled. So I have my positive x, positive 1, and a negative 1. So if I have 2x, that means I have to drag 2 of these things over. Okay, so I have 2 x's. That represents this 2x. I go to my next one, and I have a positive 3. I'm going to drag 3 of my 1's. And next, we look at our next term, okay, and we have a 4x. So I'm going to go ahead and put 4 of these x's over. Now, I don't have anything that is a negative, therefore I have no zero pairs. I have nothing to cancel out my positives here. So if I was to add these all up and add up how many x's do I have 1, 2, 3, 4, 5, 6. That's how I know this is a 6x. We have 1, 2, 3 that we are adding. Okay. Same thing for number 2. We're going to go ahead and for each term of the expression, we're going to model it with our positives and negatives, almost like using counters. Instead of using positive and negative counters, we're using ones for our constant and x's for the variables. Okay, and it says to have 8 of these. 2, 3, 4, 5, 6, 7, 8. Now I'm going to add 7. So we're going to put 7 of these 1s right here. There's 4, 5, 6, and 7. So if I was to go through and count how many x's do I have? 1, 2, 3, 4, 5, 6, 7, 8. I still have an 8x. And how many 1s am I adding? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And also our expression simplified because we combine those like terms. Okay. So sometimes, remember when we talked about adding the opposite? So if I was to rewrite number 3, so adding the opposites, right? All addition. This is what this expression would really look like. So now we can actually go through and model it the way we want to. I just have 5 x's for my first term. Then it tells me I have 2 negatives. But then my next one is a negative 3x. So now when I drag over my negative 3x, I'm actually going to put them by this one because those are 0 pairs. So we actually are going to cancel each other out. Now when I go and write my new expression, I have these x's, which is 2x, and then I only have my 2 negative 1. Okay, so that is how we can take this and break it down. Let's look at number 4. We have a 3x. So that means I have 3 of these positive x's. Now I challenge you, if you think you can do this on your own, do it on your own and then come back and check your work. I'm gonna go ahead and put all my ones in one section. So my first one, I'm gonna put my 5 1, 3, 4, 5. Then it says I need 10 more ones. So since I've already put this to 5, it makes it easy to kind of line it up. And I just gotta add another 5. Keep your work organized. It's a little less work. Alright, so that did our first 3 terms. The last term is 7x. I'm going to add 7 of these x's now. Notice I'm not going to have any 0 pairs. We're not going to be able to cancel anything on this one. So we're just going to add them all up. So how many x's do I have? Well, 2, 4, 6, 8, 10. We have a 10x plus, and then how many ones? 5, 10, 15. Which makes sense, right? Because we know 5 plus 10 is 15. All right, let's scroll down. 5. All right, we're rewriting it with adding the opposite. All right, so remember that this would be really adding a negative 4x and adding a negative 9. So that way I know how many x's and how many ones I really have. Ones, I got 3 ones. Then plus 4 negative x's. Right? I can't cancel anything. So I'm just going to put them side by side. And then it says negative 9. So 9 of these negative ones come through. So do you think we're going to have any 0 pairs when we finish this all up? And you know what? We are. We have some positive ones and we have some negative ones. So these actually cancel each other out. So then what am I left with? Well, I have 6 negative x's. But then I have primarily all negative ones, and then I 6 of them. Same thing. Now this time we have another variable. Now something you're going to find out, you cannot mix your variables together. Okay, x is a different value than y. We don't know what that value is at the time. They haven't given it to us. We can't do anything with those. We cannot combine them to make an xy. 6 and 7. All right, next I have 4 1s. 2, 3, 4. And then 3 more y's being added. 3. And a negative x. So this negative x is going to cancel that positive. So both of those are zeros. So I'm only really left with my 3 negative x's. Okay? So then those cancel. So I have a negative 3x plus a 10y, like having 10 yo-yos, plus 4. See how we took such a large expression to a smaller version of itself? All right. So basically, we have these 4 here. We're just going to take them and put them together. These are my like terms. That makes a 16x plus 3. You can do these on your own. Pause this video and then come back and check your work. Okay? All right, 2 apples and then 7 apples. I got 9 apples. I have my x's here. That makes a negative 4x minus 4. Okay, you took $5 one day, you took $8 another day, you owe $13 times how many people you called money. and then you have a constant that you can add together to get to. All right, you need to pause this, glue this in, and go on to your next sheet. The next one is going to be about our vocabulary terms. Okay, so we talked last week about how an expression is a combination of numbers, variables, and operations. Okay, they can have more than one on each of these. All right, so terms in this problem is our 2x, our 3y, a negative 4x, and a positive 10. So we took this first one and broke it down. Our constants, that's any number that is left by itself, so that is only our 10. Our coefficients are any numbers that are being multiplied to a variable. Okay, so that's our 2, 3, and the 4. Is there anything that we can combine because they are like terms? Yes. We can combine our 2x and our negative 4x. So let's do some practice. All right, so when I first look at this one, I have my terms. There are 4 different terms. 2, 3a, 9a, 5a. And we have our constants. There is only one number that is by itself, and that is our 2. Coefficients, that is these numbers that are being multiplied by a variable. That's how we know they're coefficients, and that's where those numbers come from. Not just because we like the numbers 3, 9, and 5. Like terms, all of those 3 terms with the same variable can be combined together. What about number 2? Pause this to see if you can figure it out yourself. Right? Did you get the same thing? You write down your 4 terms, your 2 constants, your 2 coefficients, and you actually have 2 sets of things that are like terms that you can put together. Okay. Same thing for 3, with 4x, 8, 5y, and a negative 3y. My constants, the only number that's by itself is my 8. Coefficients is the 4, 5, and negative 3. And any like terms, well, if I had 5 yo-yos, and my brother took 3 yo-yos, I could combine those together. Same thing before, we have 4 different terms. You notice I'm not just rewriting it as the expression. I'm putting whether it's a positive or negative. Constants. These are both my constants right here. So I have 8 and a negative 2. My coefficients, okay, are these numbers in front on the variables. And I also am going to put them as my like terms. They both have the variable b. So I can combine my negative 3b and my 5b. So let's talk about some rules that we have about combining like terms. Okay, they always have to have the same variable. You cannot combine an x and an xy. They must be raised to the same power. You notice how this one has the exponent? You cannot mix that together. Same thing, you cannot put together this. Those are not the same powers. You cannot put those together. Numbers by themselves, constants, are always added together. When identifying like terms, we circle the variable and the sign or coefficient in front of it. Okay, that way we know if it is a positive or negative coefficient with a variable. Integers are key components. We must still follow all integer operation rules. So when we're combining our like terms, we still need to follow the same signs and keep different signs of track. All right, simplify means to compute or combine like terms and reduce all fractions. okay? Because we will eventually get to where we have fractions. Okay, so this example, they showed that we have only one constant. We have two y's that we can combine together, and then our two x's. And sometimes you're going to have where they disappear. Because if you have a negative 2x and a positive 2x, their zero pairs are going to cancel. Just like when I do this one. Okay? These two are going to cancel each other out. If I have 6 yo-yos and 7 more yo-yos, so I have 13 yo-yos. And normally I'll use different shapes. I'll either use a rectangle, a circle, so I can clearly identify. And then my constant of +4. Here I have 3x and a negative 2x. So I take a beat in my head, 3 minus 2 is 1. Now notice I don't write my x with just a 1 right there. So then I have my yo-yos plus the 7 y. It's reduced. This is the best shape we can get. Alright, now I have 4a and a 10a. Together that makes 14a. I only have one b, there's nothing to put with it, so I keep that 4b as it is, and my constant of minus 3. Alright, now we have exponents. So this is where I'm going to have to keep this one together. So that gives me my 2x squared. Then I have a 5x, but there's no other plain x to put with it, so that's why we keep it as it is. And I have a negative 2y, no other y, so it stays as it is. Any pauses? Go ahead. Today's assignment is a maze. Okay, so break it up so it's not just a plain old worksheet. What you're going to do is you're going to go to start in the upper left-hand corner. We're going to look for terms that we can combine. So out of my x plus 2x plus 4y, I can put a 1x. Remember, this is kind of like that invisible 1 right there. And add a 2x. So that makes a 3x and then plus 4y. Oops, y sometimes looks like that. Now you have to pay attention. They both start over here with 3x. This one says 4y, and the other one on the left says 4. That's going to tell you, okay, I really need to go this way. Okay, now we can break it down again. What do we have that we can combine? Well, the only thing I can really combine are my constants. A 6 minus 3. Now, I can rewrite and don't use commutative property and put my 2x first, plus a 5y, plus a 3, right? So if you notice, only one of them has the plus 3. And it doesn't matter about the order of the addition, because that is our commutative property. All right? So when you go to do the next one, you have all x's. So you are going to combine all of them. Right? So if I was to write this without my variables, I have a 3 plus a negative 4 plus a 7. So 3 plus negative 4 is a negative 1, plus a 7 is a 6. So that's how we know it is 6x. Okay, there's still x's with each of these. But you have to think of them just as integers. All right, if you have any questions, reach out to your teachers.